Okay, hi everyone, and welcome back to the part 2 notes video. This one's all about continuing our discussion of finding area and perimeter of parallelograms, rhombuses, and squares. And video 1 of part 2 took us through parallelograms, and so now video 2 will take us through hopefully rhombuses and squares. It would be so cool if we could get the notes done in 2 videos instead of 3 videos. I'm sure you agree with that. Let's go then. Just so you know, though, however, I want to do the best teaching that I can do, and so I'm not going to, I want to explain it fully, at least to the best of my abilities. And so, let's hopefully we get through all of this video. If we need a third, we're going to take a third because it's important to be taught well. But let's see where that brings us. All right, so here we go. Now, the first thing you should know about a rhombus is a parallelogram, right? A rhombus is a parallelogram. Special parallelogram. It's a parallelogram where all 4 sides are the same, right? And so it's kind of like, a parallelogram is kind of like a slanted rectangle. So our rhombus is kind of like a slanted square. But again, it does contain all of the properties of a parallelogram. And so because of that, one way to do the equation or that area formula for a rhombus is just like parallelogram. Area is base times height. And so what we would do here is we could recognize like the bottom as being the base. And there are a couple ways we can draw our heights. Our height can go from here, right? Remember, base and height always make a 90-degree angle, right? And so there's your height and base. Or, and I'll do it in a different color, or, we can drop it on the outside, right? 90-degree angle, still that same vertical distance as the green line, so still considered our height, right? And so just base times height, that's formula number 1. Now, formula number 2, which is actually, for whatever reason, a more useful formula, is this. Again, this is a rhombus. All 4 sides are the same. And I want to draw a couple things into this rhombus. If we connect opposite corners, these are called diagonals. And in a rhombus, diagonals cut each other in half. And so, for instance, like the left side of this long one is going to be equal to the right side. And the left side of this shorter one is equal to the right side of it. But, and that's important, but really the formula here is going to be this. Area equals diagonal 1 times diagonal 2 divided by 2. And so the full length of this diagonal, we can consider diagonal 1. The full length of the other one is diagonal 2. So not like a little chunk, not half of the thing, the whole thing, diagonal 1 and diagonal 2. Now, it doesn't matter which one you call diagonal 1, which one you call diagonal 2. That's interchangeable, but basically this version of the formula is multiply both the diagonals together, their full lengths, and divide by 2. Just so you know, even though these are different formulas, they will not give you different answers, right? You can use either of them you want. The trick is use the one that is easiest to work with, right? And so here's what I mean by that. This says find the area of the rhombus, right? And we can tell it's a rhombus because of the 4 tick marks through the outside. All 4 sides are the same, got to be a rhombus. Now, they have given us information inside the rhombus. What I mean by that is this diagonal, part of it's 6, the other part of it's 6. Here's another diagonal right here. Part of it's 3, the other part of it's 3. So the whole thing we can call like diagonal 1. And if part is 3, the other part's 3, the whole thing is 6. And then looking at the purple one, the red one was diagonal 1, we'll call the purple one diagonal 2. Part of it's 6 and the other part is 6, and the whole thing is 12. And so since we were given diagonal information, let's use the formula that works with diagonals. Area equals diagonal 1 times diagonal 2 divided by 2. And so diagonal 1 we'll call 6, and we'll times that by diagonal 2, which is 12, and then we'll divide by 2. And 6 times 12 is 72, and 72 divided by 2 is 36. Now, we are finding the area, so this is square units. That quotation mark there means inches, and so it is 13 inches squared for our final answer. Now, in the second example, similar situation, right? Similar situation, but we got to find area and perimeter. So we need to find, obviously, the area, but we do have to know all the outside edges, because then that's the perimeter, right? We'll add all 4 outside ones together. Now, once again, they have given us some inside information. This diagonal, part of it's 4. And one thing we need to remember is that the diagonal gets cut in half. So if the right side is 4, the left side is 4 too. And then the same thing happens with the other diagonal, right? This one, part of it's 9. Well, it got cut in half. So if one part of it's 9, the other part is 9. And so let's find the area first. Remember, area, if we know the diagonals, diagonal 1 times diagonal 2 divided by 2. And so the full green diagonal is 9 and 9, which is 18. The full red diagonal is 4 and 4, which is 8. And so we just want to times the 2 diagonals together. We'll go 18 times 8, and then divided by 2. 18 times 8 divided by 2 is going to be 72. And this time, those are feet units, so feet squared. And that is our area. Perfect. And again, we applied the diagonal 1 times diagonal 2 formula. Now, the issue on this problem, and I'm going to clean this up a little bit so we can do the perimeter part, is we don't know any of the sides, right? They're all question marks right now. However, one thing that's important is they're all the same, right? So whatever we do to find one of them, then we actually know all of them. They're just the same, right? And so what I want you to see here is when we draw the diagonals inside of a rhombus, look at what shape gets made, right? If I look at the 9 and the 4, for instance, that's a triangle, right? And there are 4 triangles when we draw full diagonals inside of a rhombus. And they meet at a 90-degree angle. And so they create right triangles. And the inside are your A and B. The outside is always across from the 90, which we call C in the Pythagorean Theorem, which is A squared plus B squared equals C squared. So if we call that missing side X and we want to solve for X, we can do 9 squared plus 4 squared, and that will equal X squared. And so let's do that real quick. Let's figure out what X is. 9 squared is 81, 4 squared is 16, and that equals X squared. And let's keep going. Add those together. We get 97 is X squared. So then take the square root of 97, and X is going to be approximately 9.8. And so remember, that's what X is. But again, remember, all 4 sides are the same. So if we found X was 9.8 there, this side has to be 9.8. And that side has to be 9.8. And this side has to be 9.8. And so our perimeter is going to be 9.8 plus 9.8 plus 9.8 plus a fourth, 9.8. Now, of course, you could always just do 9.8 times 4, and that's simple as well. But when we add all these together, we should get approximately 39.4 feet for the perimeter. All right. Beautiful. We're cruising. Let's do some squares and call it a day. Now, 2 formulas for the area of a square, and they are things you are familiar with. So a square is also a parallelogram. And so at its core, the area can just be base times height, right? Base and height. And the reason we can put the height just right on here is, remember, a square has 4 90-degree angles. So base and height always create a 90-degree angle with each other. But by definition, that's how it works with a square, right? And so just bottom times the top. Now, the other thing to know, though, is all 4 sides are the same, right? And so when I do base times height, I'm really multiplying one number times itself. Anytime you multiply a number times itself, it's like squaring that number, right? Anything times itself is that number squared. And so if I just consider all 4 of these to be S, I'm going to call it S because it's just a side length. And I can call all 4 S. because they're all the same side. So they can be labeled as the same thing, right? And so it's literally just like S times S. And again, anything times itself is that thing squared. And so your area can be thought of as base times height or as just one side squared. One side squared. Now, square also has another formula, and it comes from the rhombus, because just like a square is a parallelogram, a square is also a very special rhombus. And so you can find the area of a square by doing diagonal 1 times diagonal 2 divided by 2 again. Diagonal 1 times diagonal 2 divided by 2. And so if we were to connect these opposite sides, right, the full length of 1 we can call diagonal 1, the full length of 2 we can call diagonal 2. Just so you know, they create a 90-degree angle in here. And one thing that's true about a square is diagonal 1 is going to be congruent to diagonal 2. That means they're going to be exactly the same. And each half in there is the same. And so all these little chunks of our diagonal are going to be the same. And that's important, and you'll see that in problem number 2 here in just a second. All right, so let's find the areas of these squares. In the first one, it's on a graph. And so the easiest way to figure this one out, we could try to go diagonals, but those lines aren't straight up and down or side to side, so we can't count those boxes very easily. In fact, none of the lines are straight, so we can't count any of the boxes. But what we can do is try to find the length of one side. Here's how. Let's say we drop B all the way down, and then from A we go over till we hit that, right? That creates a 90-degree angle. We can count those boxes. And so notice the units here going left and right. Every tick mark is 2. And so from our dot at A to where we hit the drop down from B, that's 1 unit. So that is a length of 2. And then from B down, notice they count by 2s as well. So that's 2, 4. That's 4. Across from our 90, I can call that X. That's always our C side. In A squared plus B squared equals C. So C squared. So we will find X by doing 2 squared plus 4 squared equals X squared. And 2 squared plus 4 squared is going to be 20. So that equals X squared. And then we are just going to take the square root of 20 to figure out what X is. And the square root of 20 is roughly 4.5. Now I want to clear all this up because X is the length of one side, right? And so I can write 4.5 here. I know that side's 4.5. But the nice thing about a square is they're all 4.5 then, right? Once you find one, you found all of them because they're all the same. And so your area, we can just call base times height or side squared. And it's going to have to be 4.5 times 4.5. And when we multiply those two things together, we get 20. All right. And that's that. Now, last problem. This one we highlighted before is going to deal with the diagonals. And what's crucial is us knowing that all these little sections of our diagonals are equal to each other. And the reason I say that is because this 7 only applies to that little top half. But the bottom half would have to be the same. Each half is the same in a square. But not only are each halves the same, but all 4 parts are the same. So this part's a 7 and that part's a 7. And so our up and down diagonal, part of it's 7, the other part of it's 7. So the whole diagonal is 14. And our side to side diagonal, again, part of it's 7, the other part of it's also 7. So the total there is 14. And so we can call like the first one diagonal 1, second one diagonal 2. And so our area will be diagonal 1 times diagonal 2 divided by 2, which is 14 times 14 divided by 2. And when you type that into your calculator, you should be getting 98, and the units are centimeters, so centimeters squared. And that is using the diagonal formula for a square. And that wraps up part 2 of notes. We did it in 2 videos today, guys. Unbelievable. Thank you for your attention. Thank you for your focus and your hard work. If you have any questions, please Google Hangout me. Please email me, whatever you need to do to get my attention, and I will gladly help you through some of these problems. Keep up the hard work. Great job on everything. I'll talk to you soon.